Okay, we're looking just a few minutes, and I want to talk with you about prime factorization. Now, probably in fourth grade, hopefully you remember talking about prime numbers. A prime number is a number that the only way you can get it by multiplying is to say 1 times that number. These are some examples of some of our lower prime numbers. 2 is a prime number because when we're multiplying, the only factors that will multiply to give me 2 are 1 times 2. 3 is the same way. The only way I can multiply to get 3 is 1 times 3. 5, 1 times 5. 7, 1 times 7, and so on with 11 and 13 and 17. There's no other way to multiply and get 17 other than 1 times 17. And there are definitely more than this. These are just my lower prime numbers. 19 is also prime. 23 is a prime number. 29. These go on and on. So there are definitely more than just these. These are just some examples. But when we do prime factorization, what we're doing, we are breaking down a larger number into all prime factors. Now, I want you to get a sheet of notebook paper and you work these with me so that you can hopefully get a grasp on what I'm doing. And at any time I get too fast, I want you to pause the video to catch up. Now, we'll start with 16. When you're doing the prime factorization, you make what's called a factor tree. You'll see what I mean by tree in just a minute. Because when I see 16, I'm going to put branches on it. And I want to ask myself, what are the different ways I can get 16? We know I could do 1 times 16. I know I could say 2 times 8. I know I could also say 4 times 4. Either of these will work, but I do not want to use 1 times 16. You will never create a factor tree with a 1 times any number in it. So I need to choose between these. Do I want to start off with 2 times 8 or 4 times 4? It doesn't matter. I'll go with 2 times 8. So I'll say 2 times 8. I'll do a dot for times. That's what you'll start seeing next year at the middle school. Now, once I get each one of these numbers, I ask myself, is it a prime number or a composite number? Now remember, a prime number is a number that when I multiply, the only way to get it is 1 times that number. Here's some examples of prime numbers. You'll notice 2 is on this list. Since 2 is a prime number, I'm going to circle it. 8 is what's called composite. There are other ways to get 8 besides 1 times 8. I could say 2 times 4, and that's what I want to use here. So I'll do a branch, and I'll do 2 times 4. Then I have to ask myself the question again, looking at prime and composite. What about 2? We circled it, so we know it is prime. Now let's go to 4. Can I circle 4 and call it prime? No, because I need to branch 4. It is a composite number. I can say 2 times 2. Prime, prime. Now I'm finished with the number 16. All of my numbers that are dangling on the ends are circled. So when I write the prime factorization, I write these in order from least to greatest. And thankfully, they're all the same number. So the prime factorization of 16 is 2 times 2 times 2 times 2. And if I multiply across, it'll equal 16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that is the prime factorization of 16. Sometimes you might even see it written like this: 2 to the 4th power with an exponent. This means I'm going to take 2 and multiply it to itself 4 times. Some people will make the mistake and they'll go 2, 4, 6, 8. When you do that, you're not multiplying, you're adding, so be careful. Now, I may have just given you a lot of information. Stay with me. Let's go do the next one. Let's go to 24. I'll also let you in on a little secret. Every even number is composite except for the number 2. So if you see an even number, you're going to go ahead and branch it like 24 is even. We know it's not composite. All even numbers are composite except for the number 2. Now that does not mean that all odds are prime. We know that 2 is an even number and it's prime. So, we know that there are some other odd numbers that's not on this list. Like for instance, 9. 9 is an odd number, but it's not on the prime list. So let's go with 24. Now let's think of the different ways we could start. We know to get 24, we can do 1 times 24, which I don't want to use because of the 1. I could do 2 times 12. That's a possibility. I could do 3 times 8. I could do 4 times 6. Any of these will work, but I don't want to use 1 times 24. So let's grab 2 times 12. So I'll say 2 times 12. And just like over here, when this 2 is prime, it's on my prime list. 2 is prime. The only way to get it is 1 times 2. Now I'll branch 12. 12's even, so I know I'll branch it. It's composite. Thinking of the ways to get 12. I could do 2 times 6. I could do 3 times 4. I'll do 2 times 6. 2 is prime. Now I branch 6. 2 times 3. You'll start getting automatic at it. Prime, prime. Let me draw my line. I'm done. All of my numbers that were left dangling, they're all circled. And I'll write these in order. Oh, I didn't mean to draw a line. That's for another lesson. I'm so sorry. Let me list them in order, least to greatest. 2 times 2 times 2 times 3. See? 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Now, another way you could write this using exponents, I could say 2 to the third power times 3. I'm just throwing that in there. You don't really have to know that. I'll probably stop doing that to keep from confusing you. The main thing I want you to learn in this lesson is how to find the prime factorization of a number using factor trees. All right, let's go to number 3. We've got the number 11. Now, if you remember correctly, 11 is on this list. 11 is already a prime number. The only way I can create 11 by multiplying is 1 times 11. So that means I don't do anything to 11 other than circle it. It's done. It is a prime number. It cannot be factored. All right, let's look at 38. 38 is an even number. Remember I told you all even numbers will need to be factored. So it's composite. So I'll factor this out. 38. Well, I don't really know immediately what will give me 38. I see that it's an even number, so I know 2 times something will give me 38. So let me come right here and divide. Sometimes you may have to use some of these numbers. I would start with 2, then do 3, then do 5, and then 7. Divide them and see if you can find a number. Watch this. 2 will go into 3 one time. 1 times 2 is 2. Subtract 1. Bring down my 8. 2 will go into 18. 9 times. 2 times 9 is 18. Subtract 0. So 38, I could do 2 times 19. Now, by the way, if I tried 2 and it didn't work, then go try 3. If 3 doesn't work, try 5. But I'll go ahead and give you a clue about 5. 5 will only go into numbers that end in 5 and 0. And then try 7. If you can't get 2 or 3 or 5 or 7 to work, then you're dealing with a prime number. You circle it. You're done with it. So let's get back. We said 2. We know 2 is prime, right? Let's do 19. What will give me 19? Is there a way to get 19 other than 1 times 19? I can't think of a way, so that means 19 is a prime number. So the prime factorization of 38 is 2 times 19. Or you've seen me do the dot, just like that. Either one of these, same thing. All right, let's do another one. Let's look at the number 42. You'll notice my numbers are getting a little bit larger. Let's think about 42. There are some different ways to get 42. I know that I could use 2 times something because 42 is an even number. 3 would also work. There is 3 times something is 42. And 6, I immediately, 42, the reason I know this one is because this is the hardest multiplication fact in the world. 6 times 7. 6 times 7 is the hardest fact in the world because people never remember that that equals 42. So let's use that. We'll use that instead of anything else. Now, remember, let me write my prime numbers over here just a minute. We had 2, 3, 5, 7, 11, 13, 17, and like I said, the list goes on and on. 19, I could do 23, 29, 31. See, it keeps going. But we don't need these higher numbers usually. We can stick with these lower ones. Now with 6, what will give me 6? It's an even number, so I know I have to branch it. 2 times 3. And those are both on my prime list. Prime. Now I'm through with 6. Let's look at 7. 7's on my list. It's a prime number. So now 42 is done. So the prime factorization of 42 is 2 times 3 times 7. Okay? Now, moving on to number 6. Write the number 54. It's an even number, so I know I'm going to have to branch it. Now, there are different ways I can get 54. I know 2 times something will work because it's an even number. 3 times something will also work. But I'm going to go with 6 times 9. 6 times 9. Now, I could have used any of those other ways that I said. Now, 6, we're going to branch that. It's an even number. 2 times 3, prime. Hopefully you're getting a little bit faster. Now let's look at 9. What will give me 9? Some people always want to circle 9, but 9 is not prime. It is a composite number because 3 times 3 will give me 9. So the prime factorization of 54 is 2 times 3 times 3 times 3. Watch me check it. 2 times 3 is 6. 6 times 3 is 18. And you'll see that 18 times 3 is 54. All right, let's go to 65. Now 65, since it ends in a 5, I know that 5 times something will work. If I don't know how many times, I can come over here and divide 5 into 65. 5 will go into 6 one time. 1 times 5 is 5. Subtract 1. Bring down my 5. 5 will go into 15. 3 times. 3 times 5 is 15. Subtract 0. Here it is. 5 times 13. Now, let's decide. Prime or composite? 5. Oh, 5 was on my list. It is a prime number, so I circle it. What about 13? 13 was on my list. 13 is prime. So the prime factorization of 65 is 5 times 13. Okay, our last one, 72. I know it's an even number, so I can definitely do 2 times something. But immediately I'm thinking about 8 times 9. I'll use that. See, this is something that will also reinforce these multiplication skills. All right, 8 is even, so I'll definitely branch it. 2 times 4. 2 is prime. 4. 2 times 2. Prime, prime. Let's come do 9. 3 times 3. Prime, prime. So the prime factorization of 72, I'll do my 2's first. 2 times 2 times 2. Then do my 3's times 3 times 3. When I multiply across, that would give me 72. Now, I hope that this has helped you to understand prime factorization. When we're breaking down a larger number into all prime factors. Now, you could take and do some other numbers to practice. This is going to really help you when we work with fractions. So I want you to really practice this, and if you have any questions, let me know. I hope you've enjoyed the lesson.